In this video, we're going to talk about a couple of other formulas or identities, talking about the sum or difference of angles inside the trig functions. Okay, so if you have sine of alpha plus beta, plus or minus beta, so it's going to be sine alpha cos beta, plus or minus cos alpha sine beta. Okay, now I want you to be aware, so you see here, this sign is the same as that sign, so that means that you keep the same sign. So if it's a plus, you write a plus, and if it's a minus, you write a minus. Okay, now for cosine, we have cosine of alpha plus or minus beta is cosine alpha cosine beta minus plus. So see, these signs are different. Okay, so it's swapped, so that means you want to swap the sign. Okay, so for cosine, you do cos of each, swap the sign, and then sine of each. Okay, now for tan is a bit more complicated. So tan of alpha plus beta is tan of alpha plus or minus tan of beta. Okay, so those ones are the same. And then divided by 1 minus plus tan alpha times tan beta. Those ones are different. Okay, so that's where you want to switch the sign. Okay, so we can use these formulas to find the exact values of other angles. Okay, so we know the exact values of 30 degrees, 45 degrees, 60 degrees. We can put those together in a variety of ways. And in particular, we can get multiples of 15 degrees. So let's just do an example here. So we'll start with example 1. Okay, this one is fairly straightforward. We just want to show you that you can't just regularly subtract them. Okay, so 15 degrees is equal to 45 degrees minus 30 degrees. Okay, but cos of 15 is not cos of 45 minus cos of 30. Okay, so if you're in degree mode, and you compute cosine of 15 degrees, you should get 0.9659. Okay, now if you instead do cos of 45, and then subtract cos of 30, we know these exact values, so I could actually compute this exactly. So cos of 45 is root 2 over 2, and cos of 30 is root 3 over 2. So if I put those together, it's root 2 minus root 3 over 2. This happens to be negative 0.1589 approximately. Okay, now these are not equal. Okay, so that value and that value are not the same. Okay, but we could find cos of 15, the exact value, using one of these sum or difference formulas. Okay, so we know that cos of 15 degrees would be equal to cos of 45 minus 30. Because 15 is equal to 45 minus 30. So now I want to use the cosine identity. Okay, so this is going to be cosine of 45 degrees times cosine of 30 degrees. Okay, and then I change the sign. So my sign here is a minus. So my sign in between them is going to be a plus. Okay, and then I don't know why I use brackets sometimes and not other times. So then it's going to be sine of 45 times sine of 30. Okay, now we know all these exact values. Okay, so cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Okay, sine of 45 is also root 2 over 2. And sine of 30 is 1/2. Okay, so this gives us root 6 over 4 plus root 2 over 4. Okay, as an exact answer, or you could write it if you want as root 2 over 4 times root 3 plus 1. Okay, either way, it's approximately equal to 0.9659. Okay, it's the same number that we got up here for cos of 15. Okay, but now we have the exact value as well. However you choose to write it, I don't care. Okay, so you can use the ones that you know to find other ones. Okay, so I'm going to leave example 2 for you to try. Okay, obviously you're going to want to do this in radians instead. So you want to think about which ones you know and how you can put them together to get 7 pi over 12. Okay, I'm also going to leave example 3 for you. So you want to find this cosine, this value. So it has 40 degrees and 10 degrees, which are not nice ones. Okay, so you want to figure out what you can do to figure out what that equals, okay, without using a calculator. Okay, so let's just write here, no calculators. So let's try number 4 here. So I want the exact value of cosine of alpha minus beta. And these are the things that I know. So I know sine of alpha is 3 over 5, sine of beta is 1 over 5, and alpha and beta are acute angles, so they're between 0 and pi by 2. So they're in quadrant 1. Okay, so this tells me alpha and beta are in quadrant 1. Okay, so I know all the trig functions are positive there. So what I'm going to do is make a triangle for alpha. Okay, so if sine is 3 over 5, sine is the opposite over the hypotenuse. So that's going to be 3 and that's going to be 5. And this side is going to be the square root of 5 squared minus 3 squared, which is 25 minus 9, so that's 16. So this side's going to be 4. Okay, then I'm also going to make a triangle for beta. Okay, same idea. So this is 1, this is 5. So this side is the square root 5 squared minus 1 squared. Okay, so that's going to be 25 minus 1, so square root of 24, which I could take out 4 there, so this is 2 root 6 on that side. Okay, so from these, and knowing that, well, actually, let's do these separately. Okay, so from this triangle, I know cosine alpha. Okay, it's going to be positive because we're in quadrant 1, and it's the adjacent over the hypotenuse. So it's going to be positive 4 over 5. Okay, now I know it's positive, okay, since it's in quadrant 1. Okay, so all the trig functions are positive there. Okay, so from this one, we know cos of beta is positive 2 root 6 over 5. Okay, so we know cosine alpha, we know cosine beta. So we can find cosine of alpha minus beta. Okay, so using the formula, it's going to be cosine alpha, cosine beta. And now remember, for cosine, we swap the sign. Okay, so it was a minus, so here it's going to be a plus. And then it's going to be plus sine alpha, sine beta. Okay, and now I know all these things. So this is 4 over 5 times 2 root 6 over 5 plus sine alpha is 3 over 5 and sine beta is 1 over 5. Okay, so that's 8 root 6 over 25 plus 3 over 25. So I can put those together. They have the same bottom. So 8 root 6 plus 3 over 25. Okay, and that's our exact value. Okay, which is what they were looking for. Okay, that's good enough. So I'm going to leave, so this one is a little bit simpler. I'm going to leave number 5 for you to try. Okay, and then we just have one more thing. So we can use these also to establish different identities. So I'm going to leave number 6 for you to do and do number 7 instead. So we want to establish this identity. Cosine of alpha minus beta over sine alpha cos beta is equal to cotan alpha plus tan beta. Okay, so remember how we do this. We pick one side. I think this side is the more complicated side. And so you could try either. Okay, this one I sort of know what I'm going to do with. Okay, so I have ideas on the left-hand side. Okay, so I'm going to start with the left-hand side. Okay, so cos of alpha minus beta over sine alpha cos beta. Okay, so using the identity, I know that the top is going to be cos alpha cos beta plus sine alpha sine beta. Okay, and that's over sine alpha cos beta. Okay, so this is using by the difference formula for cosine. Okay, so now what I want to do, when I have addition on the top of a fraction, I can actually split it up. So I'm going to rewrite this as cosine alpha cosine beta over sine alpha cos beta plus sine alpha sine beta over sine alpha cos beta. Okay, so to get from here to here, this is just a fraction rule. Okay, so if I have a plus b over c, I can write it as a over c plus b over c. Okay, so that's a fraction rule. And now I see that these things have things in common. So over here, there's a cos beta over a cos beta, so those cancel. And in this term, sine alpha over sine alpha is going to cancel. Okay, so I'm left with cosine alpha over sine alpha plus sine beta over cos beta. Okay, now notice that these guys are both alphas. Okay, so same angle, and I have cos over sine. So cos over sine is the same as cotangent. So this is going to be cotangent alpha. And over here I have, again, same angle. So this time it's beta. And it's sine over cos. So this is going to be tan beta. Now I look back up, and that is exactly the right-hand side. So I have, in fact, established this identity. Okay, so that's the idea. So you can use these sum difference formulas to help you as well to prove even more identities. Okay, so those are the sum and difference formulas.